We are going to be talking about equivalent expressions. Equivalent expressions are expressions that are equal to each other. So it means that they have to equal the same amount. They just look different in the way that you set them up. But they still need to follow what you see in the expression. It has to match it so that it's equal. So for example, what we're going to do is we are going to list equivalent expressions that are equal to these expressions I have written down. So we have numerical expressions up here, and then we have algebraic expressions down here. So these ones have letters, these ones just have numbers. So let's start with the first one. So here we have 1 times 2 plus 3 times 3. So we're going to list as many equivalent expressions as we can. I'm going to list a few. There might be more than the ones that I list, but I'm going to try to list at least 3 or 4 that could be equal to that. So one that I'm thinking of that's very simple is where you would simplify this. So 2 times 1 is 2, and 3 times 3 is 9. So 2 plus 9 is equivalent to this particular expression. Okay, another one that could be equivalent is, so I see this 3 times 3, and I know that exponents are where you have repeated multiplication, so I'm going to represent that with an exponent. So for this one, I could do a couple different things using the exponent. So I could do 1 times 2 plus 3 to the power of 2, or 3 squared. And that would be equal to that as well, because 3 squared is 3 times 3, which is what I have. Another one, I could just multiply that, so I could do 2 plus 3 to the power of 2. So that one also would be equal to all of those. Another one that we could do is we could spread this out again, so we could do 2 times 1 is 2, plus, and then I could do 3 times 3 on this side where I leave the exponent alone and I just write it out as 3 times 3. And then another one you could do, probably the last one I could probably squeeze up here, is I could do 1 times 2 plus 9. And that would also represent this, because again, I have 1 times 2, and then 3 times 3 is 9. So these would all be equal to that original expression. Okay, another one that we have here is 4 times 5 plus 4 times 5. Okay, so how do I represent that? So this one I can do a parentheses. So for this one, I see that I have 2 of the same thing, so I'm going to do 2 times, and then in my parentheses, I'm going to do 4 times 5. Because I have 4 times 5 2 times. So I have 2 of those, so I can just times it by 2, and then I've got a new expression. Okay, another one that I could do is, again, I could just multiply those. So I could do 20 plus 20. And that would be the same as this. And again, you also need to think about that these have to equal that expression. And 5 times 4 plus 5 times 4, that has to equal 40. So I've got to keep that in mind, that all of these have to equal 40. This one up here would be 2 plus 9. So all of these, I need to make sure we're equal to 11. And so that kind of helps you think about how these need to match up. So another one I could do is, I see that I have 2 4s and 2 5s. So you could pull out one of those 4s times, and then the parentheses, since that's gone, you can add what's left inside. So I could do 5 plus 5. So that would be 10 times 4 still gives me 40. Do you see that? And then another one I could think of is just then keeping one of these like this. So you could do 4 times 5 plus 20. Squeeze that in. And that one could also work. And you could flip-flop that. You could do 20 plus 4 times 5. And all of these expressions would be equal to that one, and they all equal 40. All right, here's another one. 7 times 8 plus 7 times 1. Okay, let's do the simple one again. 8 times 7 is 56 plus 7 times 1 is 7. So that would equal that problem. Okay, another one we could do is, again, do you see how I have two 7s? So I'm going to pull out that common 7. I'm going to times that by then what's left, 8 and 1. So I'm going to do 8 plus 1, okay? And that's going to be 9, and 9 times 7 is 63. So all of these needed to equal 63. So I can see so far I've got 63 with all of those. Okay, then the other easy one is just to do 50. We could do 7 times 8 plus 7. And that would work, or you could flip it. You could do 56 plus 7 times 1. And that would also work. So these are all equivalent expressions to that particular original expression. Okay, let's look at the algebraic expression. So here I have 4 times a. So a very easy one that's equal to that is you take the dot out. So this would be 4a. Remember, those are equal to each other. Another one is where we represent this with repeated addition. So another one could be a plus a plus a plus a. And now we can just split that into lots of different combinations. So I could put these two a's together and these two a's together. So that's another one. You could do 2a plus 2a. Then we could split that up again. Maybe I want to do 3 a's and 1a. 3a plus a, and that would also equal 4a. So as you can see, there's lots of different ways that you can write 4 times a. Okay, let's look at this one, 6n plus 8. All right, so many different ways we can do this. Let's break up the n. So the first thing we could do 5n plus n, because 5n plus n equals 6, okay, plus 8. And that's also equal. Another one we could do, which is just like this one, is we could do n plus n plus n plus n. That's 1, 2, 3, 4, 5, 6 plus 8. And that would also work. Then we can just all kinds of different ways that we can split that up. So we could split that up into 3 and 3. So we could do 3n plus 3n. Do you know that we can even represent that 8 with an exponent? Because I know that 2 to the power of 3 also equals 8, because 2 times 2 is 4 times 2 is 8. So we can even split up that 8. So one more I'm thinking is we could do 2n plus 4n, because 4, 5, 6, and then I could even split this up with multiplication. Maybe I want to do 2 times 4, and that would also be equal to that. So there's so many different ways you could write this. I could go on and on and on, but all of these are equal to 6n plus 8. All right, last one. 5u plus u plus 2. Okay. Same thing that we did here. We can break up those n's. We can even put them together. So like here I could say 6u, because 5 and 1u would be 6 plus 2. And that would be equal to that. Another way is you could split that up again. So we could do 3u plus 3u. And then we could even just add 2, or we could do 2 times 1, because that also equals 2. And then the easy one that I like to do is, remember, we always can just list out all those u's. That's 5, 6 plus 2. Okay, so as you can see, there's lots of different ways that we could write this. One more, we could just break these up again. You could think about 4u's plus 2u's plus 2 would also work. So as you can see, there's so many ways that you could write that. But these are all what we call equivalent expressions, because they all equal our original expressions that we started with. We just wrote them in different ways.